Good morning, this is Ms. Billerbeck, and we're going to talk about ratios involving rational numbers. So the ratio of similar quantities, A to B, is written A to B as a ratio or A to B as a ratio where B cannot equal 0. We cannot have a 0 in the denominator because it makes it undefined. So if we have a bag consists of 25 balls and 15 red balls, so 25 green balls and 15 red balls, find the number of green balls to red balls. Oh, if you hear that noise in the background, by the way, that's a bunch of kids out behind my house. Those are baby goats. They are eating the weeds for fire suppression. They are very cute, but they are very loud. So we have 25 green balls and 15 red balls. So it said green balls, 2 red balls. So the green balls go first. So there's 25. And then the red balls are 15. Now we see they both end in 5. So we know they're both divisible by 5. So let's reduce this ratio. So we have 5 to 3, because 25 divided by 5 is 5 and 15 divided by 5 is 3. So this would be our ratio of green balls to red balls. The number of red balls to the total number in the bag. Well, we have to add the total number in the bag then. So that equals 40. So we are doing red balls, which are 15, to 40 balls, which are the total number of balls in the bag. Again, they're both divisible by 5. So we have a ratio of 3 to 8. So we have the masses of 2 balls of sugar. A and B are 750 grams and 1 gram, respectively. Now, respectively means when we have A is listed first, the first weight goes with A. So this is A's weight. B is listed second, and that's listed second. So that's B's weight. So that's what respectively means when you see it, that this is written in order and then the weights are written in order. So find the ratio of the mass of B to the mass of A. So we're finding B to A, not A to B. Okay? So that's important. So B is listed first, which is 1. We don't need to write gram because they're both grams. They have similar units. So it's 1 to 750. And that's all we have to write. So simplification of ratios. So if I have A over B to B over M, that's actually the same thing as M times A to M times B. And it's actually the same as A to B, because they're all being either divided by the same thing or multiplied by the same thing. But when we simplify it, it becomes A to B. So this works for any integer. Integers go from all the whole numbers or counting numbers, including 0, and all the negative numbers. Those are integers. So for any integer m, when m it does not equal 0. And that comes into play because we can't have a 0 right here in the denominator. Otherwise, we'd have an undefined situation. So let's express each ratio in the simplest form. So we can't have a fraction. So what we're going to have to do is figure out how to get rid of that fraction. So one way we can do it is to multiply by the reciprocal. So this is called a reciprocal. Okay? It means it's a flipped over fraction. So if we multiply it by that on one side, we have to do it to the other side. So this actually is 2 over 1, and then this cancels to 1 over 1, which is just simplified to 2 to 1 ratio. For this one, what we have to do is we have to get it into an improper fraction first. So we're going to multiply right here and add right here. So multiply and add. So 3 times 1 is 3, plus 1 is 4. So we have 4 over 3, 2, and then 4 times 7 is 28, plus 4 is 32 over 7. So we have a 3 and a 7 on the bottom. So 3 times 7 is 21. So let's multiply this side by 21 and this side by 21. And we'll put a little 1 over there. So we know that there are 7 3s in 21, and we know that there are 3 7s in 21. So now all we have to do is multiply 7 times 4 is 28, and 3 times 32 is 96. So at this point, we can say, hold on, these can be reduced. This is not the simplest form. So I'm thinking that perhaps they're both divisible by 4. So when we divide them by 4, we get 7, 2, and then there are 2 4s in 9, carry a 1, and 4 4s in 16. So now we have our simplest ratio, 7 to 24. And 7 does not go into 24. So when we're dealing with decimals, our goal will be to move these decimals over 3 places. So how we do that is we multiply by 1,000 on both sides. Whoops, that's 100 there. Now it's 1,000. So that gives us 360 and 153. Now we can say, this must be reducible, but how? And then we think, well, the 153, it has fewer factors than 360, so let's do a factoring tree. So 1 plus 5 is 6, plus 3 is 9, so that's a multiple of 3. So we can take a 3 out. When we do that, we get 51. 5 plus 1 is 6, that's also a multiple of 3, so we can take another 3 out, and that gives us 17. So when we look at, well, 3 times 3 is 9. 9 divides 36. 9 times 4 is 36. So we can divide this by 9. So let's see what we get. So 9 goes into 36 4 times, and there's a 0. And 9 goes into 153 17 times. So we have a ratio of 40 to 17. And 40 is not divisible by 17. It's a prime number, so that's as good as it gets. All right, let me get these other examples in here. So if we have ratios of 3 quantities, Here's an example. So if I have AB equals 710, so my goal is going to be A to B to C, and BC is 15 to 8. So now let me write this down. So A to B is 10, but over here I have 15 to 8 is B to C. So somehow I need these two the same. So I look at their factors, and I look at this factor, and I see I have a least common multiple of 30. So I need to get a 30 in here. So that's what that needs to be. And how I do that is I multiply by 3 here and here. So I get 21 to 30 on this side. Now, if I multiply by 2 on both of these, I get 30 to 16. So my final answer then is going to be 21 to 30 to 16. All right, let's look at example 5. Okay, we have an alloy, copper, zinc, and tin, and they're combined in the ratio of 2:3:4 by weight to make an alloy. If the weight of a piece of alloy is 2.7 kilograms, find the weight in grams of copper and zinc. So first, let's add up all of these. So we have 2 plus 3 plus 4 equals 9. So some 9 times some multiple equals 2.7 kilograms. So if we divide this by 9, we can find out what this multiple is. So the multiple ends up being 0.3 kilograms when we divide 2.7 by 9. So let's go back and figure out, well, what's the copper? So we have really, it's 2m to 3m to 4m. And we just found out what the m is. So we multiply for copper. It's 2 times 0.3 kilograms. And then that's 0.6 kilograms for copper. For zinc, we have the 3, because zinc's the second one, so it goes with the 3. So 3 times 0.3, and we're going to be in kilograms, is 0.9 kilograms. Now they didn't ask, but if we wanted to find the tin, we could do the same thing. So the tin is 4 times 0.3 kilograms, and that's going to be 1.2 kilograms. Now, if we add this up, guess what it's going to add to? 2.7 kilograms. So we have 6 plus 9 is 15, plus 2 is 17. Carry a 1. 1 plus 1 is 2. And it checks. All right. So let's try another problem. So we have 3 friends, X, Y, and Z, share 132 computer games. That's why they never do their homework, because they're playing computer games all the time. So the ratio of X's share to Y's share is 2 to 3, and the ratio of Y's share to Z's share is 1.2. So how many computer games does each friend get? All right, so first we want to make an X to y to z. So our first ratio for x's share to y share is 2 to 3. But then y share to z share is 1. Whoops, let me write that over here. 1 to 2. So we need the y's to be the same. So that means we need to multiply this one by 3. So that gives us 3 to 6. So now we have x is 2 to 3 to 6. Okay, we also know that it's 2m to 3m to 6m. Okay, and we know the total share equals 132. So if we add 2m plus 3m plus 6m, that should equal 132. So that's 11m equals 132. So when we divide by 11, we get m equals 12. So we can go back to here where we had for x's, so we have x, which is 2m, which is 2, let me write it down here. So x is 2m, which is 2 times 12, so that's 24 games. Y is 3m, which is 3 times 12, which is 36 games. And z equals 6m, which is 6 times 12, which is way too many games for one person to have and actually do well in school and get some sleep. So this friend has 72 computer games. That's way too many. Okay, so we have one more example. Okay, we have the weights of May and Terry are in the ratio of 3 to 4. If May's weight increases by 6 pounds while Terry's weight decreases by 4 pounds, the ratio of their weights becomes 24 to 29. Okay, so our ratio 3 to 4 can be written as 3m to 4m because we have some multiple m that we can multiply. So now let's go back and change things around. So if we have May's weight increases by 6 pounds, so May is 3m and she's adding 6 pounds. Terry's weight decreases by 4 pounds. So we have 4m minus 4 pounds, and that's going to equal the ratio of May, which is 24, over Terry, which is 29. So now we're going to cross multiply. So we end up with 29 times 3m plus 6 equals 24 times 4m minus 4. So we distribute, so 29 times 3, 3 times 9 is 7, 27, carried 2, and 3 times 2 is 6, plus 2 is 8, m, plus, and then 6 times 9 is 54, carry a 5, 6 times 2 is 12, plus 5 is 17, and then that 4 times 4 is 16, and then 4 times 2 is 8, plus 1 is 96, and then this is just minus 96. All right, so let's move some things. So let's subtract the 87m from this side. So that gives us 0 plus 175 equals, and then when we carry 1 from here, we get 9m minus 96. So now we need to move the constant to the constant. It's a minus 96, so we add it. So we have 0, 9m equals, we add this, we get 11, 17, 271. So now we have m here, so we don't really need this here, so we can divide by 9. Okay, oh, that's a 4. I'm like, something's not right. There we go. So 270 there, now it's all better. Okay, so we divide by 9, and then there's 3 9s in 70, and then 0 9s in 0 equals m. So when we answer the question, we have 3 times 30, 4 times 30. So the original weight was 90 to 120, and this would be pounds. So that's how you would solve when you have the ratios change. All right, well, that's it. I hope you have a lovely day. Bye-bye.